We'll continue with our other three presentations, and we'll take some more questions.
Thanks. Yes, and I'm happy to invite Jin Joo on the. Here we have the next four stage, and the Joo is third-year resident at St. Paul's Hospital in Korea, and we've already heard a lot about light and understanding the molecular effects of light. So we are very excited to hear the study.
Thank you for your kind introduction. My name is Judy Jin Joo, a third-year dermatology resident from St. Paul's Hospital, Catholic Medical School in Korea. Today, I'm going to talk about various wavelengths of light-emitting diode light, regulate the proliferation of human dermal papular cells, and the growth of hair follicles via Wnt beta-catenin and the ERK pathway. First of all, I'd like to announce that this study has no conflict of interest. Human dermal papular cells, DPCs, play a key role in the regulation of hair cycling and growth. Inductive signals from the DPCs are believed to stimulate the proliferation and differentiation of follicular keratinocyte into the hair shaft. Wnt beta-catenin pathway and MEK kinase pathways play an important role in hair growth regulation and cellular response to extracellular stimuli. However, whether light irradiation regulates those pathways is rarely studied. Low-level laser therapy has been known to stimulate cellular activity in various cell types. However, in vitro studies on DPCs irradiated by light have been rarely performed. Low-level laser therapy also have been hypothesized to stimulate hair growth, especially in various non-scarring alopecias. The hair mass laser cone emitting 655 nanometer light was approved as a safe therapy for the treatment of male and female androgenetic alopecia by FDA. However, the effect of 655 nanometer light on hair growth is not consistent across the clinical trials and animal experiments. Light-emitting diodes, LEDs, is an excellent alternative for delivering continuous optical wavelengths other than laser. Most studies investigating the effect of LED on hair growth have used wavelengths that range from 635 to 650 nanometer. However, the exact underlying mechanisms are not well understood. The goal of this research is to investigate the effect of different wavelengths of light on the proliferation of cultured DPCs and on the growth of human hair follicles in vitro, and to examine the effect of light on Wnt beta-catenin signaling and MEK kinase pathways in cultured DPCs. Four wavelengths were chosen: 415, 525, 660, and 830 nanometer with dose of 1, 5, or 10 joule per square centimeters. Human dermal papular cells were cultured. Then they are irradiated with LEDs for 48 hours, and cell proliferation was determined using a magnetic assay. Effects of light on the MRI expression of beta-catenin, XN2, Wnt3A, Wnt5A, and Wnt10B in DPCs, and protein expression of beta-catenin and cyclin D, and the phosphorylation of MARC, ERK, and JUNK in DPCs was detected by real-time PCR and Western blot respectively. 60 anosine hair follicles from one donor were cultured according to Philpot's method. Anosine hair follicles were cultured with different wavelengths and doses of light for 5 days. Elongation of each hair shaft was measured on 5th day. The result shows after 48 hours, all four wavelengths resulted in significant increase of DPC proliferation. 660 nanometer 10 joule per square centimeter was the most potent. DPC proliferation was increased by 130% to 160% as those increase from 5 to 10 joule per square centimeter. 830 nanometer 1 joule per square centimeter is also significant, as much as 150%, but to a lesser extent than 660 nanometer line. Beta-catenin MRI expression was significantly enhanced by 660 nanometer 10 joule per square centimeter and 830 nanometer joule per square centimeter. All four wavelengths significantly increased SN2 expression, which is known as direct beta-catenin targeting. Win3A expression was significantly increased by 660 and 830 nanometer 10 joule per square centimeter. Win5A expression was significantly increased by 450 nanometer 1 joule per square centimeter and 660 nanometer 5 joule per square centimeter compared to control. Win10B MRI expression was markedly enhanced as much as 10-fold to 15-fold by 525 nanometer 10 joule per square centimeter, 660 nanometer 5 and 10 joule per centimeter, and 830 nanometer of all doses. Then we measured the effect of light on the protein expression of beta-catenin and cyclin D in DPCs. Beta-catenin protein expression was amplified 2.7-fold and 2.9-fold with 525 and 660 nanometer respectively. Cyclin D, which is the target gene of beta-catenin, was significantly increased by 525 nanometer 10 joule per square centimeter and 660 nanometer 10 joule per square centimeter and 830 nanometer and 10 joule per square centimeter. Light induced a significant increase mark and arc phosphorylation in contrast to jump. Furthermore, to determine whether MET kinase pathway was involved in DPC proliferation by light, DPCs were pre-treated with 20 micromole PD98059, a MET kinase inhibitor that results in the inhibition of DPC proliferation prior to light irradiation. 450 nanometer, 525 nanometer, and 660 nanometer of all doses, and 830 nanometer of 1 and 10 joule per square centimeter significantly counteracted the effect of the inhibitor on DPC proliferation. Therefore, light promoted DPC proliferation by activating MET kinase pathway. In order to examine the effect of light at organ level, we performed ex vivo culture of whole human skull hair follicles. Hair follicles irradiated with 450 nanometer 10 joule per square centimeter grew 42% longer, and those with 660 nanometer of 1 and 10 joule per square centimeter grew 20% and 15% longer than control respectively. Other wavelengths has no significant effect on hair shaft elongation compared to control. In conclusion, this study suggests that LED light has a potential to stimulate DPC proliferation, possibly via the activation of beta-catenin signaling and ERK pathway. To our best knowledge, this is the first report which investigated the effect of light on DPC proliferation and underlying mechanisms. This is the photo of 8th World Congress for Hair Research in Korea last year. Thank you committee and organizers for giving me this opportunity to present our research work again. Finally, I want to thank my professor, Dr. Hong Kang, for participating in his research. Thank you all for listening.